Hey, Mr. Dahl here, MDC Sting. This is the 5th year we've been doing it. MDC stands for Mr. Dahl's class. Students came up with it years ago. We stuck with it. The sting is obvious. Hornets. So, this is the video newsletter for the beginning of the school year for design robotics. What I try to do is use video to give a window into the classroom of what's happening. Especially our classrooms are all over Edina now with hybrid, EVA, and our situation. So that's why we do it, and I think it'll be good. Our first project was to use the design process that we learned initially, looking at solving problems through the eyes of an engineer, and it was the marble challenge, which is students had to have a marble course that was at least 36 inches long, had at least 6 change of directions. One of them had to go uphill, start from a stop position and stop at a stop position. So what was so nice about it is I was proud of the students and how they solved problems looking at it from different angles, different perspectives, because there were different ways to solve this problem. It wasn't one size fits all. And I think you'll see that in the videos. Take a look at this. I like that design.
This is the marble challenge. The problem is that the marble must start from a stop position, travel a minimum of 36 inches, travel uphill, change direction 6 times, base must remain stable, come to a stop position, and it has to be repeatable. The constraints are is the due date. First, it will start up here at a stop position and go down the marble course. And it has an end point, and that's stop there, and then it has to be repeatable. Whenever a real world connection is that whenever you are doing something, there will always be many steps and problems before you reach your goal. I learned that what you think will happen, even if it is obvious, might not happen.
Hi, I'm Addie, and this is my roll track. So the criterion constraints.
So I'm gonna have it go down then 3 more times because it has to have 6 changes of direction, and at the end there's gonna be an uphill about like that.
Cool.
Hi, my name's Ella, and this is my overall project. And I did like a maze thing, and my criteria is that it has to go 6 different like changes and stuff.
So this is me and Hudson's marble course thing. If you pull this tab up, it will release this marble that will go down a ramp onto another ramp, and then that ramp goes to another ramp, and so forth. It changes direction 6 times. We counted before we made it, and well, as we were making it, and it'll come out here, go down here, jump off that into there.
All right, I see it. Hey, it worked this time.
Our marble run, these are my associates. So it had to be at least 36 inches. This is like 3 feet long if you're including these turns. It's 3 feet long like that too. So it had to start from a stop position, so we got it right here. It has to end in a stop position, so this little ridge is where it'll end. It has to go uphill, so that's what this little like jump thing is. What else am I forgetting? It has to be repeatable, right?
Yeah, and it travels 1, 2.
Yeah, it has to 36 inches. What do you do? It has to change direction 6 times.
Okay, let's see it.
Okay.
Well, you just saw it.
Okay, wait. Alex has to push the button and record.
I did.
It only goes for 10 seconds.
And go.
Stop position.
Yay! That's our marble run.
Hi, my name's Granny, and this is my marble. Oh, This is my marble run course. Okay, so the problem was that we had to create a marble run course that was at least 36 inches long and had 6 changes of direction, and one of them had to be an uphill slope. And so when I was designing my project, this was really similar to the drawings I had, so I kind of knew that I was going to go with this way, like this method, and so now I'm going to demonstrate it. Yep. So connecting this to a real world problem, I think this is kind of similar to how the cars go down ramps in parking garages. Obviously, it's a lot more slanted, but if it was going around, it'd be really similar. So what I learned from doing this project was you have to have perseverance, because this took me a really long time to do, and it took a lot of tries to get it right and to get it to work. And it took a really long time, so I learned from this project that you have to stick with something and you have to keep going. So, thank you.
This is my marble challenge for design robotics, and we have to get this blue marble from here to down there. And it has to move a total of 3 feet or 36 inches, and it does, because here we have 2 feet, 3 feet, inches, 2 inches, 3 inches, 12 inches, another 12 inches, 5 inches, one more 5 inch, and this little back piece there, that is 1 inch. And it has to change direction 6 times, and it does. 1 change, 2 change, a third change, 4, 5, and 6. It has to go uphill, and it does right there, and you can see that it goes downhill a lot. So uphill, downhill a lot. So that's it. And something, I don't really know what I learned. I guess I learned that gravity is a constant. It doesn't count as changing a direction. And I also learned that when you're planning to make anything, that you need to know your measurements and you need to know the scale, because you really have to have it planned out as much as you can. And a couple more times to show that it is repeatable. And then you can repeat it right after. Cool. Thanks. That's it. Bye.
Hi, this is my marble project. I have some of these, and then I have a loop right here, and this is my very small hill. And then I have a paper towel roll, and it comes out right into the cap. And to get it to work, you need a bigger marble, because if you have a small one, it kind of flies out the side. So you need a bigger one, and you also need to drop it from a certain height. I learned a lot from this project. I learned about how to make good designs and how to make ones that look cool and work well.
Alright, this is George and Charlie for the Marble Challenge, and here is attempt number 1. Oh, there we go. See? And here is the thing, and we'll show you the steps. So it starts up here, goes 1, 2, 3, 4, uphill, 5, 6, down to a stopped position. Goodbye.
Hello, ladies and gents. I'm very tired. So if I'm acting as energetic as always, I'm very sorry. So anyway, oh great, I dropped it. Okay, so here's my marble. Nice. So we'll talk about the criteria while we go along, but first let's define the problem. So the problem is that we have to make a marble run. I'm gonna put the marble down. So criteria: start from a stop position. Correct. Have a stable base. Yes. 36 inches long. It's about 40, so yes. So yeah, let's get started. Okay, so it went up. It's going through the turns. It stops. Yay. Okay. Let's do it again, and then we'll talk about constraints. Okay, so there we go. Okay, so the constraints that we had was making sure that the marble didn't fall off the edges of these nice little turns. So the turns were my biggest constraint because they were just, the toilet paper rolls for the turns were really flimsy and the marble would like just go off the edges of them. So as you can see, we have a double toilet paper roll on some of them, very fancy. And then we also have a bunch of extra push pins. We started out with 2 on each, and now we've made our way to like 6 on each. So I don't really know how that happened. But, so the real world problem I connect this to is, here, I'm just gonna set it down while we go. I connect it to that in 5th grade or 4th grade, I think we went to like a, what is it called? Oh, I don't know what it's called, but it's an engineering museum, and they had this like 50-foot marble run, and it was so cool. It's just amazing how long these marble runs were. They were just really cool. So yes, and then I learned that you should, hello, here's my part 2. I'm sorry, I don't know if there's a time constraint, but I needed to finish talking because I talk way too much, so I don't have time in the video. So I learned that you should have a good mindset about things and you shouldn't procrastinate because really, once you really get into it and you're on a work grind, it goes by so fast and it's really not that hard. So yeah, bye.